Good morning to all. In this video we continue our AXI tutorial series. Up to now we are seeing the AXI master slave, then AXI stream. Now today we are focusing on the AXI Lite. So for that we just wrap up the what we seen earlier in terms of the signaling. So basically AXI 3 corresponding to write and 2 corresponding to read. Earlier saw my videos, so if you're not, you just go back to the earlier series of AXI and check regarding this all the series. What is the code for the AXI Lite and how we can simulate with the memory attached to the AXI Lite slave. So before going into detail, we just go back to the our presentation. We are going to AXI Lite now. Difference between the AXI and the AXI Lite is that the AXI is corresponding to very high performance, high bandwidth applications like DDR, GPUs, processors, interface memories, like that. But for considering the low complexity and low bandwidth for the register simple interface, we are taking the part of or take the some derivative of the AXI as a AXI Lite. It is a low complex, low bandwidth. It is generally used for the control registers, configure the interface, simple peripherals that can be plugged to this AXI Lite, so that minimum signaling wires will be there and we get the required things done through this AXI Lite. So the basic difference regarding the data width in AXI, the data width can be 3264. This can be possible, but in AXI Lite it is 32. Addressing is full memory map access. It is simple one. Individual channels are there for read and write. We can say that read and write will not be in simultaneous way. It is a time division multiplex kind of thing, but here it can have both things simultaneously. No burst, there will be the latency, uses, configurations, symbol transactions, no out of order execution there. We are targeting the one simulation setup where the AXI Lite is connected to the memory and we emulate the AXI master to try to read and write from this memory. This will be the screenshot from the there will be one AXI Lite and we emulate the master for the signaling of these 5 channels. 3 correspond to the write process, 2 correspond to the read process. Obvious there will be read if we are considering any memory as a slave, so obvious there will be the address, then the write response and data. Similarly read address, read data, like that. Okay, so these are the corresponding 5 channel signaling names. So basically they start with the AW means address, write address, W means write data, B means write response, AR means read address, R means read data, like that. So you can remember these things. Let's start with this is a log of the iverilog while we are past the AXI Lite slave and the corresponding test bench for that. Okay, so in that test bench I write 3 locations 8, C and 10 with the data 200, 300, 400, and similarly I read the 3 locations 8, C and 10. I get what I write. These corresponding waveforms are like this is the write address, that is 10 C, then 10. So write data is 200, 300, 400, and when I try to read this, we have to place the read address 8, C and 10, and we get corresponding 200, 300, 400, and this waveform from the VCS. So similarly I get the same thing, map of the memory, where I get the data at 8, 12 and 16. This is a 8 C C and 10. Okay, we get the 200, 300, 400. Okay, we back to the code of the AXI slave. This is a module AXI Lite, and these are the clock reset, the corresponding channels, that is address, data and the response. These are the signals names. Similarly for the read address, channels are there, so read address and the read data, these are the corresponding signaling. In this we use one memory for to read or write as a slave device through this AXI Lite. These are the reset conditions. We are latching the address first. When these two are active, we are latch the address, not complete 32-bit, but we are using the 8-bit depth of the memory, so we are use the lower side of the address from the 32 bits. So we get this address. On that address we have to write the data, WDATA. Okay, so these are the corresponding responses for the write. Similarly for the read address, we latching the address first of the 8-bit only. On that address we have to provide the outcome of or stored data to the RDATA, and these are the corresponding responses for the read process. So this is simple. I hope you got all these things, basic things. If you follow my series, AXI series, then you get all this. In test bench code we take some register wires, similar for the AXI mask component instantiation, device under the test, generation of the clock, initial block. These are the for the VCD file. These are the initial cases for the address, read, data, everything. And once the reset is deasserted, we are looping we are writing the write transaction multiple times. Here we are using 3 times, so we have to place the address, incremented address by 4, then data as well. So we have to make this AW valid and W valid be ready signal equal to 1, and after that we just place some message. This is the address, that is data, which going to be we write, and after 1 clock we release the signals. Okay, in VCS we need this additional clock, but in this iverilog it is not to be. Okay, so for the read process we kept the same thing. In spite of these things, we target the AR address and the AR valid and the R ready. After the positive X clock and negative clock transition on the A clock, we pick the data from the address and R data, which is going to the memory data. So it will show on the that message these are the addresses and these are the data we are going to write, and these are the reading process addresses and the data corresponding. Okay, so we start with the iverilog first. I create one exe for the providing the sources to this iverilog and get the log on the console as well as the waveform window from the GTK. Okay, we just need to select these 2 files. This is a AXI Slave Lite, and this is a test bench. These 2 files, we just click the compile and simulate. This command window, we get the all the messages like these are the 3 address and 3 write datas. These are the read transactions, corresponding address and corresponding data. From this it is valid that it is properly writing and reading the memory through this AXI Lite. So in this my while recording this now, it's not showing anything like that. So I already get the snap from this like this. Okay, so we switch back to the VCS simulation for the same. Okay, so for VCS we are already on the VCS folder. So we check the make file for VCS. If you remember my earlier EDA series, in that you just refer the EDA VCS tool. In that video you get all the details how VCS makefile can be set. The main part is here, the file list, where all the source listed in this file. So you just check this using the pause and play button what this makefile contains. Okay, back to the all files bin all files.txt, where I list the two source files. One is for testbench and one is for our AXI Lite Slave. Okay, I can go back to the check that files under the code AXI Lite. Okay, this is our source file where we kept the same file here. For the completion I just open and show you in this video, otherwise it is the same file. Okay, then our test bench tb AXI Lite. Okay, these are the signals, wires, instantation, clock generation, dump file, repeat block for write and read transactions. Here I just add one passage clock. Okay, so we go back to the in the VCS we just have the command like make top equals to name is of the top, that is our top AXI Lite. Okay, just enter the creating one this DB window. Just Control A, select all, or we go under the slave part. Just Control all, Control 4. It will pop up one DB waveform window. Just hit F5, zoom bit. You get the message here like this is for write transaction, this is for the read transaction with the address 810C and the corresponding data 200, 300, 400. Okay, you also get the waveform that I show in the presentation. Okay, these are the writing address for 8C, then corresponding data WDATA, that is 100, 200, 300, and this is for AR read data addresses 8C10, and the corresponding RDATA, that is 200, 300, 400. And if you check the memory, you get the data at 8, then 12, then 16. Okay, in this way we can simulate on VCS. And please subscribe my channel, as there is a very less viewers for this kind of videos. So whoever and whenever you saw this kind of video, please subscribe and support, and please make any comment for any requirements or feedback to improve this kind of things and please hit like button. Thank you.